Hi, my name is Richard Zadorozny. I'm a software engineer on the Threads team working on our Android app. And I want to talk to you today about making threads for Android, especially using Jetpack Compose to reach 50 million people. So I'm going to talk about this going through the journey of building it, starting with asking ourselves, what are we building and how fast? To how we built this with Compose, especially some of the things that we learned by building an app of this scale that isn't really covered in the Compose documentation, and then going over some of the post-launch stuff that happened. So the first question was, what are we building and how fast? So you probably know by now that we built the Threads app very quickly. But our first deadline was actually just 1 to 2 months for our initial minimum viable product. So we knew that there was appetite for a new text-based conversation app in the public. And we wanted to have something ready if an opportunity presented itself that we wanted to get something out there. But building a new social network app from scratch in 1 to 2 months is very difficult. So we had to figure out what would be the fastest way that we could get something ready that was high quality. At Instagram, we pride ourselves on having a high quality bar. So we had to figure out how to get that right balance. So we decided that we would build using Instagram as our base. And we realized that we could reuse our servers and our data layer and then try to build threads on top of that. And you can kind of think about a Threads post as an Instagram post, where just the media is optional. And there's a few more details there, but that's a pretty good approximation. So we just had to figure out how could we build our Threads UI and slightly different business logic on top of Instagram. Well, around this time, we had been investigating declarative UI frameworks for Instagram. And Jetpack Compose is the new modern declarative UI framework that's built by Google. By this time, we had started to make some initial tests inside Instagram. We started to lay the foundation of Compose in Instagram and saw how it would work in our systems. But we know that refactoring a large app like Instagram takes a long time. We have a lot of performance cares inside the main Instagram feed. It has to be really fast. And making sure trying to change the UI framework while maintaining that high performance would be really challenging. So with Threads, we have a new opportunity where maybe this would be an appropriate way to get a lot of expertise in Compose really quickly and sort of catalyze adoption throughout the rest of Instagram. So we had to make a decision, what would be our best option? With views, because Instagram is built with views, we could adapt our existing Instagram UI for Threads. And all of our engineers have prior expertise in views. We also know that views are a complete framework, but it is kind of legacy now. Google has said that all new components would be built in Compose, but not necessarily in views. And with Compose, we didn't know if it would actually do everything we needed to yet, but we knew we could interop with views and fragments if we needed to. And we didn't have a lot of expertise with Compose yet, but we saw that the ramp-up time was actually pretty good and that people really appreciated the nicer developer experience and how it was easier to apply modern practices. So we saw Compose as a risk because it was some unknowns there, but I saw views as a big risk too, because we've seen that trying to refactor and adapt our Instagram UI to something new takes a long time and it's really challenging. So we decided on Compose. So let's talk about how that went. And again, I want to focus on some of the stuff that isn't covered in the Compose documentation, stuff we've discovered by building a big app of this scale. Of course, no matter what, you always start with an empty activity. Nothing's different at Meta about that. But 2 days later, we have something that actually looks pretty close to the final product. We have our threadline decorations on the side there. We have our feed. We have the buttons, the reply text at the bottom. We have the tab bar. And it scrolls. It's looking pretty good. But it is mock data. This is not real data at all. And a lot of those tabs are actually blank, but pretty good progress so far. In another 2 days, we have real data. So the nice thing about building the UI from scratch is we could get something that starts to look good really quickly, which is really motivating when you're trying to build something really fast. But don't be fooled. It's still not ready for 50 million people. You still have to build the rest of the owl, so to speak. There were no images there, the carousels, videos, activity feed, likes list, search. There's so many features that go into building a complete social network app. And so something I want to say is, I talk about a lot about Compose in this talk, but a good app is more than just a good UI framework. It's also the people. And I feel very fortunate to work alongside a group of highly talented native Android engineers here at Meta to build this, and without which this wouldn't be possible to build it so quickly. We also took a very principled approach to development. We didn't have an example of what a Compose app would look like at this scale. So we had tried to apply clean code principles as responsibly as possible, avoiding early abstractions and continuously iterating on the architecture and design as we went. Because we kind of were figuring out what we were going to build as we were building it. So we did run into some challenges, and I want to talk about some of the ones that I found most interesting. The first is Compose upgrades. Now, when we started building threads, we knew that performance wasn't quite where we wanted it to be, but Google was making significant advancements in performance. So we wanted to upgrade Compose as we were building the app. And this wouldn't be so bad, except that at Meta, we have a mono repo where we have Instagram, Facebook, Messenger, the Oculus app. Every app we've ever released is there, including ones we're still working on. So if we try to upgrade Compose, we're actually upgrading it for all of these apps. And these apps may not really be using Compose yet, but Compose depends on Jetpack libraries, which may or may not depend on Kotlin upgrades. And so this upgrade actually becomes a big deal, because if this breaks any one of these apps, you cannot land that change. But we've been making significant progress here, and we've been able to upgrade to the last version of Compose 1.5 just 30 hours after it being released, and then rolled it into the next version of Threads for Android the next week. So it's just a really big undertaking at this company, but it's super important. All right, I'm going to go into a technical detail now. And I could honestly go into this topic for about an hour, but I'm going to go over it at a very high level. And if you find this interesting, I encourage you to check out the blog post that should be going out around the same time with more details about some of the challenges here and some of the fixes that you can do. So the subject is stability and recomposition, and notably how this can affect the performance of your app, especially as it starts to grow. And there are kind of 4 categories that play into this, or ways that stability and recomposition can become a bit of a problem. So let's go into a little bit about each. The first one is unstable types. And if you've looked into performance and stability in Compose, you've probably heard about this already, but it gets into a little bit more detail here. So stability in Compose is the idea that a class or object inside a class or object, if any data or value inside there changes, Compose can observe that change and make smart decisions about what to recompose. And this is really good for performance. The problem is that you have to opt into this behavior. So by default, if you create a new class, it is considered unstable. When Compose reaches an unstable type, it will no longer make an assumption about what's inside and will favor correctness over performance. It could recompose a lot more of your UI than is really necessary. So an example here, we have a function myComponent, which takes a few argument types. Context, that's not stable or immutable. We have our own custom class, which hasn't been marked as stable or immutable, and we have a list. All of these are actually unstable types. There are some pretty easy fixes here. One is, if your class can be stable or immutable, you should mark it as such. And if you want to learn more, check out the blog post for what those mean. Some classes have immutable alternatives, like immutable list. For anything else, you need to try to figure out how to defer access to those unstable types as much as possible. So in this case, instead of passing context as an argument, you could get it as a composition local. So it's no longer an argument in that function, and so that argument can now be skippable. The next one is composed modifiers. So in our previous example, we updated our function so that all the arguments were now stable or immutable types. However, it's still possible to pass values to prevent that specific function call and prevent it from being skipped. So in this example, myComponent is given a clickable modifier, which looks pretty innocent enough, but clickable is built with the composed modifier. This means every time you call my component or you get to this my component line, you cannot skip that call. And so we have to try to fix that as well. There are a few fixes. One is if you can move that compose modifier inside the component, now that component can be skipped and you're kind of pushing the problem further downstream, which might be fine for your purposes. So you could pass an on-click lambda instead. That lambda could be considered stable. Another example, if it is one of your own custom modifiers, you could change how it's written. You could use a simple or a regular composable function to build the modifier instead. Or, if you're interested, you could try the new modifier node API that Compose is working on. It's a little bit more advanced, but it could be better for your scenario. Another issue is Lambda Recreation. This one was a big gotcha for us in our app and hasn't really been talked about, but I think it's really important to be mindful of it. So this still gets back to unstable types. And you might know about the Compose compiler reports that you can enable, which analyze a function and tell you if its arguments are stable or not. But it doesn't tell you what's happening inside your function. And that's still actually very important. So in this example, we have an on-click lambda, and it's calling our view model, but it's okay. We made our view model stable, so that's fine. And it's using a context. We can see just above, we've used the composition local to get that context. So we should be safe, right? Nope. Context is still an unstable type, and we're passing it into this lambda. So a bit about lambda reuse in Compose. Compose will actually try to reuse a lambda instance across recompositions. So every time your code is being called, it'll try to reuse the same lambda instance from last time. But if that lambda is capturing an unstable type, it will not reuse that instance. It will always recreate it. And if your lambda gets recreated, that my component call cannot be skipped. So that's one scenario. But this problem isn't only in unstable types. It could happen in cases that seem fairly innocent. In this next example, we have perform action that's using a row and its ID. Let's say row is an immutable type. There are actually no unstable types here at all. The issue is that even if a row ID may never change, the instance of that row object might change. Say, for example, you create a new copy of that row where isLiked has been flipped from false to true. We have a new row instance. And so because that lambda captures that row instance, it's a new instance, and so it has to recreate the lambda. So it prevents skipping again. So these are some things that you have to watch out for. Now, those cases might seem simple enough, but as your app is growing, there could be a much bigger impact from this problem. See here, it's still the same problem. We have an on-click lambda that's capturing context, but look at the nested calls that are happening here. Let's say we haven't split up our function into smaller functions yet. The impact becomes very widespread. How does context get from there to here? Well, look at all those lambdas. It means that every lambda has to capture context to pass it to the next one. So if that my scaffold line enters recomposition, that whole thing has to be recreated, which is pretty silly because context didn't even change anyways, so really nothing should have happened. So those are some of the examples that we had seen, and that's still kind of a high-level overview. So if that's something you're interested in, please check out the blog post. We go into much more detail over there, or hit me up in threads. All right, the other example was too many arguments. So Compose encourages a very detailed API for each composable function that you add. You try to pass very primitive data or individual lambdas to your component. And this works very well because you know exactly what that component needs and what it needs to give back. However, as you start building your app, these components start to get a bit more detailed. The list of arguments just grows and grows. And for threads, our feed rows have over 30 actions and events that it can trigger. And there's several problems with this. One, it becomes really hard to reuse this function. Imagine having to call this function with 50 arguments in like 5, 10 other places. That's really hard to manage. And then with all those individual lambdas, it becomes really easy to capture those unstable values or have those other recomposition issues. The other issue with lambdas is that you can't call them with named arguments. And if it's just one argument, that might be fine. But if they start to get a bit more complex and have multiple arguments, it's not a really great developer experience. So the fix, fortunately, is pretty simple. And it is to group those data objects and lambdas into groups. The important key is that when you do these groupings, it should be thinking about what my component needs exactly from the outside. It should never be what something else wants to give to my component. So my component is never getting anything else that it doesn't need. And the other nice thing is because the events are put into an interface, you can call those functions with named arguments again, so it is a nicer development experience. I would still just encourage you to not default to this approach. Try to find those functions that are becoming a bit unwieldy, and then see about applying this pattern over there. The other nice thing about interfaces is that it actually still gives you a lot of flexibility for how you're implementing this in each one of your screens. All right, so that was a lot about challenges, but we did actually have a lot of fun using Compose as well. So I want to talk about some of the ones that I found the most fun. The first one is the threads icon spinner that shows up at the top of our feed. I was really happy that we got to get this into the initial launch. And there were two things about Compose that made this easy and fun to build. The first is anything built in Material or the other examples that Google has are pretty modular. So back before, this pull to refresh behavior was in a swipe refresh layout, which just had all the logic in one big class. But in Compose, there are several components that you can pick and choose what you want. So we could just reuse the Material pull to refresh modifier for our spinner. And this gives us gesture detection and some state. And then we can just put our custom render and layout logic on top of that. The other nice thing was with Compose's coroutine-based animation API, it was really easy to build this sequential animation for the spinner. So I can kind of show you a little bit about what that kind of looks like, or how you can think about it. You can kind of do this or imagine this with a launched effect, which happens whenever you start refreshing the feed. It's just a simple loop. While you're refreshing, animate to the end, animate back to the beginning, and keep going until the refresh is done. And then once that loop is finished, you can just animate, fill the rest of the way from whichever side you ended up on. And I just find this really easy to read and follow compared to what we might have done before, which was the listener approach where you're just kind of jumping between the functions, but it's just harder to find what the sequence actually is. So that was really nice. Another example is shared element transitions. Now, Compose doesn't have an API for this yet, but we found it pretty easy to build in a way that makes it really easy to reuse across all of our screens. So an example is when you tap on a picture in Feed, it'll zoom in to the full screen viewer, and you can fling it to dismiss. These are two different screens in our Jetpack navigation-based navigation system, but it's really easy to do with how we have it set up in Compose. And I really like this other example too that probably not a lot of people see, which is the picture jumping between two screens that are moving if you're adding some alt text, some accessibility text to your pictures. Another fun one was the UI tuner. And this one's more of a developer feature than something that we publicly show, but maybe this audience finds this interesting. I think what was really neat is how easy it is to integrate a system like this into your app. So Compose does have a live edit feature where you can change code in your app and see it reflect immediately in your app. But what about those times when you're not at a keyboard and maybe you're giving your phone to a designer and you want them to check how it feels or give some suggestions on specific animation values? With our UI tuner, this becomes really easy and really easy to put anywhere in the app that you want it. So for this example, we have a shared element transition when you zoom into a profile picture, but we just have to change the code to call tunable spring spec instead. And then just the presence of this function call in composition will make this field show up in the UI tuner where you can tweak the properties and have some fun with how the thing shows up. All right, so that's some challenges and some fun stuff. Let's talk about the launch. So it's probably not too big of a surprise, but it went well. We launched in 5 months since we started coding the project, and we quickly reached 50 million installs on Android. So that 100 million installs that we got was pretty evenly split between Android and iOS. And I was really happy that our quality was on par with the iOS app and we had the same feature set. And there were some growth features that we really enjoyed too. One of them we call the golden ticket, and Cameron talked about this a little bit. We had the same thing on Android. This isn't built with Compose, just standard views and canvas drawing. I thought it was really neat that the team was able to build this with a few gradients, shaders, and a bit of love. And also this Threads joiner number in Instagram turned out to be so popular that we after a while we took it out, but we had to put it back in because it was just so popular. And in terms of interesting launch bugs, this one was one of my favorites. This only happened on Android 9 devices that had enabled dark mode. And it is gnarly. So when I saw this, I thought for sure it would be a Compose rendering bug, like a backwards compatibility thing. But when I reached out to the Android team, they recommended to look into underdrawing. And sure enough, that was the actual issue. So it wasn't a Compose bug. It was a different Android view kind of system bug where the window background wasn't being set properly on these devices. So fortunately, easy fix, but it's a beautiful bug. All right, so going forward, we are very happy with how Compose worked for building the Threads app. And so we're going to continue doing that. And we're also excited to pursue adoption in the rest of the main Instagram app and throughout Meta. For Threads itself, we're going to continue iterating on the app to try to deliver the best value that you're looking for in a text-based conversation app. Since we launched, we added edit, content search, and we have a bunch of other stuff that we hope you like. So that's how we made Threads for Android, and I hope to see you there. Thank you.